Hey everyone, welcome back to another video. So today we're going to be talking about the standardized value. So this is sort of related to standard deviation. So if you haven't watched that video, I highly recommend you check it out right now. But anyways, let's get into the standardized value. So this is going to be nice and simple. First, let's just get the definition of the standardized value out of the way. So the standardized value is essentially the number of standard deviations. I'm going to abbreviate that. A point slash value is away from the mean. So what does that mean? So we know that if we have, let's say, a graph, right? Let's just have our normal graph, and it's a normal distribution. So as that normal distribution, right? That's a bad drawing, but you get what I'm trying to say. And you have like your first standard deviation, second standard deviation, right? But what happens if the point you get is somewhere in between, right? It's not exactly on those benchmarks. So let's say the point is right here. Then what are you going to do? How are you going to measure that? How are you going to compare? Okay, so then why do we use standardized value? Well, one of the reasons why you would use standardized value is so you can compare different distributions, right? So you can compare different distributions. And it's useful just to evaluate data. Let's say you have a set of, you'll see in the problem later on about comparing grades, like how you did relatively to the mean. And that's really important for just comparing data in general. It gives you some key insights and helps you really gauge like how relative something is to the entire variability. So let's move on to the problem here. I think it'll make a lot more sense once I display this on the problem. So let's pick a different color. Let's just use that light green. All right, so Kua earned a grade of 50 on a normally distributed test, so that we can imply that with a mean of 45 and a standard deviation of 10. On another normally distributed test with mean 70 and standard deviation 15, she earned a 78. On which of the two tests did she do better relative to the others who took the test? So when it says relative to the others, so we know we're comparing a data set and there's different data sets for each of these situations. So let's just write it out and it'll make it a lot more clear what kind of data we're working with. So the first test, she got a grade of 50. So let's just write X because that's the point we want. The mean is 45. So let's just write mu. I'm just going to have that symbol represent 45 as the mean, and it's not letting me write again. This is so fun. 45. And then a standard deviation of 10. Annotate that as that symbol. Standard deviation of 10. And on the second test, I'm scroll down a little. On the second test, she got a 70. However, this time the standard deviation was 15. Let's just write so as everything's in line. So, oops, she actually got a 78. Misread that. And then the mean was 70. And then the standard deviation was 15. All right, perfect. So how can we use this data to actually find what we're trying to find, which is the standardized value? Well, there is an equation for this, but there's also a pretty simple way to think about it. But I will write out the equation because I think it makes it easier to just visualize the data. So let's get the equation out. It's going to be this symbol, which just represents the standardized value. And what you're going to do is take your original, so this is just your value, whatever you're trying to observe and see the change or like variability between the points. That's your value you're trying to find X. You're going to subtract the mean. And the reason you do that is because let's say you have X is less than the mean, then you're going to get a negative number, which makes sense because when you account for standard deviations, it's going to be in the negatives then. So then we're going to have this divided by the standard deviation, and this is going to give you let's just plug in the numbers now, right? So like let's say if X is 50, so we're going to write 50 if it'll let me write 50, subtract mu, which is 45, divide this by 10. That's going to give me 5 over 10. So this first test has a standardized value of 0.5. So that's 0.5 positively above the mean of a standard deviation. And so that's relative to this value. So in reality, it's really like 5. Now let's move on to this one. So we have 78 minus 70. So now it's got a positive value. So we know she's doing relatively better than the mean. And then let's have this over 15 because that's the standard deviation. And that's going to give us 8 over 15. And we know that 7.5 out of 15 is equivalent to 5 over 10 because both of that is 0.5. And so, since 8 over 15 is greater than 7.5 over 15, that means this is going to give us a value greater than 0.5. And so that is going to be our answer. And so she did relatively better on her second test. All right. So that does it for this video. If you have any other questions, just leave a comment and like the video.